Concentration units, when we deal with pollution, are often expressed in parts per million, or even parts per billion. Let me try to illustrate this with some water. I've got two 100 ml beakers here, and we'll fill them up to approximately 100 ml each. So this is just plain water. As my pollutant, I'm going to use some red food coloring. And I've weighed it. One drop is approximately 0.05 grams. So I'm going to put 2 drops in the 100 mils. That means I've got about 1/10 of a gram of food coloring in here. And since 100 mils of water is roughly 100 grams, we have then 1 part per 1,000 in terms of the food coloring. So this is 1 part in 1,000, or we can call it 1 part per 1,000 of my pollutant. I'll now take a dropper and take 2 drops of this solution and put that into the next container. So 1, 2. So now I've got 2 drops in this container. We now have a concentration of 1 part per million. So I've taken 2 drops of the 1 part per 1,000 and diluted it by another factor of 1,000. So this is now 1 part per 1,000. You really can't see the color at all. And a part per million is a very small quantity. So small, in fact, that we cannot really detect it unless we have very sensitive instruments. A part per billion would be taking 2 drops of this and putting it into another 100 mils. And you can see that that would not even be noticeable. Another way to illustrate the idea of very dilute solutions is to take a little bit of gasoline, put a little bit in a test tube, and take 1 drop of that and add that to a 2-liter pop bottle filled with water. So I've added 1 drop. Then we put the cap on and shake it really well. Now normally gasoline, of course, is not miscible with water, but at such low concentrations as what we have here, the gasoline itself does mix. So the concentration of the gasoline in the pop is approximately 10 milligrams per drop. So I've got 2 liters, so it's 5 milligrams in 1 liter. So it's roughly 5 parts per million. Now that's quite a bit yet, but we can now open it up and take a whiff of it. And the smell of gasoline is still very strong at a concentration of 1 or 5 parts per million. You can dilute this further and ask students if they would be willing to drink water containing, let's say, 0.1 parts per million. How about 1 part per billion? Would you be willing to drink that water? And that may bring home the idea of what we do to our water supply when we contaminate it at very low levels with various chemicals. Even at a level of 1 part per million, you can readily smell gasoline.